Uh, our next talk is Oliver, and he's a student at Oak Grove High School in San Jose, California, with a passion for aeronautics, and he's going to talk to us about typography being used in runways and in other settings. Thank you very much, Oliver. Have the floor.
Okay, thank you. Let's see if I can get my presentation shared. Okay, everything, can everybody see everything?
Yes.
Okay, so as Paul said, my name is Oliver Austin, and the presentation that I am going to be doing is an exploration on machine interaction with text type for visual-based navigation systems in aviation. So a bit about me. Like Paulo said, I'm at high school at Oak Grove High School. I'm going to be graduating in 2022. I'm also the co-president and co-founder of Oak Grove's Makerspace. And I'm also a student pilot taking lessons at Sundance Flying Club in Palo Alto, California. So an introduction to the project I've been working on. Visual-based navigation systems usually consist of one or more cameras coupled with a computer. The use of cameras in these navigation systems usually allow for high levels of precision when controlling vehicles, leading to improved safety and just improved accuracy overall. Today, in the broader industry, you see these being used in autonomous cars, such as Tesla's automobiles, where they've just recently transitioned to using fully camera-based autonomous control for driving. On the aviation side, the aviation industry is focusing more on the commercialization of autonomous unmanned aerial vehicles, or drones. And these are going to be integrated into the airspace fairly soon. And of course, we want these to be able to navigate and fly safely. And in the most critical stages of flight, which are takeoff and landing, we want these systems to be as accurate as possible. And this is where vision-based navigation systems can become very useful. Looking at the current industry applications, Airbus is one of the leaders in these visual-based navigation systems and autonomous aerospace vehicles in general. They have an autonomous taxi takeoff and landing program, or ATOL, which is trying to create the first fully autonomous commercial airliner that can transport passengers. They're also working on developing a UAV or helicopter that is, again, autonomous and going to be put into use in the French military or French Navy by the end of 2021. So from all this, I decided, and because this is a typography conference, I decided to create a driving question for this presentation, which is the current font used for runway designators suitable for visual-based navigation systems in autonomous aerial vehicles? In order to start to answer that question, first off, we need to take a closer look at runway designators. So runway designators are these combination of numbers and letters that are usually found at the beginning and ends of all runways. They give the runways a unique code corresponding to the runway's magnetic heading. So for example, if the runway has a heading of 194 degrees magnetic north, that then gets rounded down to 190 and then gets simplified. The third character gets cut off for simplicity's sake, and it turns into runway 19er. The letters, on the other hand, distinguish between parallel runways. So in the case that there's more than one runway which has the same heading, these letters will be used to tell them apart. As you can see in the background image, we have a runway 30 left and 30 right because they both align with 300 degrees. Looking more closely at the fonts, we can see the fonts is highly geometric. It actually has no name. So for the remainder of this presentation, I will be referring to it as the ICAO font for the sake of simplicity. But we can see it's highly geometric, and its main purpose of being geometric is so then groundskeepers can easily recreate them who don't usually have typographic training. And like I said, this is made by the ICAO font, or ICAO, which is the International Civil Aviation Organization, which is why I'm going to be referring to it as the ICAO font. So before I looked at starting the project, I wanted to first identify some problematic characteristics when using machine learning and visual-based navigation systems looking at these fonts. And I came up with three major problems. The first one is that the number one in this font is very similar to other straight lines that can be found on the runways, which may lead to mix-ups. The second thing is that the numbers 6 and 9 are exactly the same. They're just flipped over, meaning that if in the case that you're looking at the numbers upside down, the characters can get easily mixed up. The third thing is that in the case that there are time marks on top of these numbers, which in many cases there are, they could make the characters 3 or 5 look very similar to an 8, which again, all these things would not be suitable if you want to have a safe and reliable operation from these vehicles. So first, let's take a look at combining typography with machine learning. In order to do that, we need to take a look at how machine learning works. It uses three major steps. First step is collect data sets for training a model. Step 2 is training that model. And then step 3 is using the model to interact with new data. So the model is a file that has been trained using the data sets to recognize certain types of patterns. This is the fundamentals of how machine learning works and deep learning works. And you train this model over the set of data, which provides it algorithms that it can then use to sort the new data. So step 1, it's collecting data sets. So in my case, I chose to use two separate data sets. First off, I wanted to look at the relationship of the ICAO font with other fonts in I wanted to look at the relation between those fonts. The second one is I wanted to see the real world applicability with the ICAO font on actual runways with other things around them. As you can see in the multi-font data set, I had 31 different fonts. And the key thing is the classes are 0 through 9, L, C, and R. The classes are what is used to distinguish which image corresponds to which item. So for example, a 0 would be in class 0 because it's a 0 and so on. And I made sure, like I said, to include the ICAO font. The real world data set consists of 137 uncropped images, which then got cropped down to 143 cropped characters, and it has the same classes. So step 2, training the model. First, we start off with the data set, which then is fed into a machine learning algorithm. In the case of my project, I used PyTorch, which is fairly lightweight, fairly simple to use, and has a lot of documentation. This then creates that algorithm that can then be used later on by the Onyx model once it's exported to interact with the new data sets. As you can see here, it's kind of the same thing. That Onyx model then interacts with the new data sets, and that's where we get our prediction of new data and the confidence percentage. Confidence percentage is how confident the algorithm is that it's gotten the answer correct. So looking at my project in particular, I had two options for categorizing the characters in the images. I have classification and I could have detection and object localization. The major differences between these two are that classification only predicts the class of one item in an image, which limits its usability, but that labels the image with the predicted class and the confidence percentage. Detection and object localization, on the other hand, identifies the location of one or more items in an image and is able to draw a bounding box around the found items and label that bounding box with, again, the class and confidence percentages. So looking at the multi-font data set, I used the classification method for this because there's only one character per image, which seems sensible to use. And as you can see, depicted by the orange line, the ICAO font significantly underperforms relative to the majority of the other fonts. The majority of other fonts are upwards in the 90% confidence range, whereas the ICAO font doesn't even pass 60 or 70%. Taking a closer look at the individual percentages and comparing the ICAO font to the highest performing font, you can see there was improvements in the ICAO fonts, but the percentages are very low still. The lowest percentage in the last one is around 24%, which is very low for being used in like an industrial application. Whereas the highest performing fonts is all upwards of 90 and upwards of 95 even, which is really good. Now, turning to the real world data set, this significantly underperformed from where I thought it would. I thought it would perform really badly. It performed even worse. I used the classification method, so then, because that was what was easiest to use and most accessible to me. And that's why I cropped down to individual characters. And as you can see by the average confidence percentage, both of those figures do not meet the minimum of around 80% accuracy to be considered usable in a system. And this 80% is what allows us to say this system is safe to be put into operation without having to worry about it failing. In this case, this is going to fail majority of the time. It's not safe to use. The second trial is double the length of time to train it, but noted here, I put that even though it was trained longer, it's not significant enough to say that it will continue to improve when trained for even longer. So looking at that, how do we improve those results? First way is we could potentially change the fonts. And as you can see, I have the ICAO font here and side by side with the highest performing font, which turned out to be Illumi in our data set. As you can see, there's quite stark differences between these two, although they do share similarities. These two characters, the 0 and the 6, were actually one of the lower performing ones in the ICAO font, and I think also in the Illumi font, which leads to other questions about maybe it's not the font itself, but how the characters are recognized. So some improvements you can make is round out some of the corners and make the characters more different than each other. And there's just a lot more that you could do to improve these. On the other hand, the more practical approach, with me being a high school student, there's no way that I'm going to be able to convince an international organization to change their font in order to make things safer. So taking a more practical approach, the first thing I can do is potentially collect a larger data set. My initial data set consisted of 11 images in the real world per class. So that equated to about 143 images overall, which is way too few to train a decent model on. The places that I was limited were that I could not find enough images to train the model on Google. And so I'd have to do more experimentation out in the real world, taking the photos myself in order to increase that dataset size. The second option is training the model for longer. By training the model for longer, it gets used to the algorithm, or it gets used to the patterns in the images, and it's able to refine that algorithm over time. Although that won't work in the cases like with a small data set, where it has a very finite number of images it can base its references on, and just eventually won't yield any significant results. The third option is to use a better machine learning algorithm, but that is limited by the processing power of the GPU, and it comes at the cost of increased training time and power consumption. And that's kind of the reason behind why I chose PyTorch as my training algorithm, because it's very light and it could be done on a very low power GPU that could be implemented into these unmanned aerial vehicles. So before I finish my presentation, I do want to acknowledge some people. I want to acknowledge my mentor, Ms. Jennifer Claudio, who introduced me to Tech User Group and helped me with all the conferencing stuff. I also want to thank the research assistants who originally helped me crop the initial multi-character data set, because that was like 400 odd images that I had to crop. I cropped some of them, but it was way too much to get the project started in a reasonable amount of time. So great thanks to them. So yeah, thank you for listening, and I will be here if anybody has any questions about what I've talked about. So.
I do have a question, Oliver.
Yeah.
How is the knowledge and the shape of this font passed around the world?
Can you repeat that?
How is this font passed around the world? The font that's used for runways.
How's it the best around the world?
Yeah, I mean, you say there's not even a name.
Okay.
How does it get reproduced?
So it was set in place by the international or the ICAO, and their main goal was making sure that it can be reproduced easily for those groundkeepers who were painting the numbers, and so then they didn't need to give them typographic training to create more elaborate characters. So it's very boxy, very simplified. You can easily mark it out on the runway and get it done very quickly. And so it was implemented by them as a standard. Just that's how it happened.
So they give just the vertices and let them fill it in with straight lines.
Yeah, pretty much. Yeah.
Okay.
Boris, you have your hand up.
Very interesting work, and thank you very much. With the ICAO books are really very boring to read, so I applaud that you found this font there. I have a question. You found where machines make mistakes in recognizing with digits and letters. I wonder whether people would make the same mistakes with the same letters. You can probably, there are in the literature, people do it. They demonstrate a letter for a short time and ask people to tell what is letter, and you probably can recruit the high school students to do it. They're very good experimental audience. It would be very interesting to repeat this experiment with humans and see whether humans perform the same or better, and whether the most mixed characters are the same. It would be a very interesting addition to this research.
Yeah, so yeah, I've discussed that a bit. The problem is finding the people and getting people to want to participate in the research, which in some cases it's easy, some cases it's not. But that's definitely a way that this project could expand, for sure. So.
Yeah. I would suggest taking your classmates in school.
I guess, yeah.
Okay, but very good, very interesting research.
Thank you.
Oliver, you have a question from Jeremy Just asking if you have tried OCR-A and OCR-B in your tests. Do you know these two fonts?
No, I don't know those fonts, but yeah, so I haven't included them in my set, but I assumed that because you're asking about that, they could produce some interesting results in comparison to it. But I'll definitely take a look into that.
Yeah, it's the fonts are called OCR-A and OCR-B. Okay. And there are two fonts which they're sold right now by Adobe, and they have been created for studies in optical character recognition back in the 60s. And you see them all over the place. Once you see them, you start identifying, oh, this is OCR-A, and this is OCR-B.
Okay, yeah.
You start seeing the world with a new lens.
Yeah, okay. I'll definitely take a look into that, and I'll see how that can help the project.
So the other question is from Paul Danese. Thanks for the fascinating talk. I may have heard incorrectly, but it seemed like the size of your training set was quite small, about 100 to 200. Can you automate the interrogation of Google Maps to get more data, for example, runways? Also, have pilots made errors misreading skid marks on 3 and 5?
Okay, so to answer the first part of the question, yeah, my data set is quite small because I was limited by Google Images. The use of Google Maps, I have thought about that to broaden my data set, although my concern with that is that it's not going to be the same as actually using pictures from planes landing, because with Google Maps, that is an ideal situation. You have a high resolution image with a top-down angle, and of course you can rotate the globe a tiny bit to get an angled approach. but I don't see that as good enough to use in the training data set, because you need to train for those scenarios where you need to train for the worst case scenarios. If you train for the best case scenarios, it's not going to work most of the time, because most of the time things aren't the best case scenarios. As for automating it, yeah, you probably could. That would be quite a bit of work considering how many runways, and you'd probably be able to use keywords and find stuff, but that's out of my realm of knowledge. And then the misreading part, I haven't heard of pilots making mistakes. And one of the things with going back to a question that was asked before about making mistakes between it and how people and machines could make mistakes, one of the things that the pilot has to assist them is they already know which runway they're going to be landing on. So they know which characters to expect. And they usually have maps of the airport as well when coming into approach. And of course, you can add that into the knowledge base of the machine, but then that takes up memory, it takes up space, and it takes up processing power to also access that. So if you're trying to make a lightweight system, then it's best to try and look at the characters and look at the runway and not reference any outside sources. So.
All right. How could you use Google Maps satellite photos to create your training set?
Okay, so that's similar to what I just answered, but
yeah,
you could probably, the way I would go about it is I just probably take screenshots, because you can rotate Google Maps or Google Earth, so then you can have like a 3D view. I rotate that and then zoom in and have it at different distances away from the runway. So I have the different resolutions of the characters and different sizes of the characters. And also go around in from varying degrees of approach. So in some cases, you're not approaching the runway straight on all the way in. In some cases, you're turning into the runway. And so it needs to be able to read it from that angle. So I go around, pretty much do a 360 view of those characters, which would take up a lot of space. You'd have thousands upon thousands of images. But that's one way that you can add it to the training set and actually make it a lot more reliable.
Well, thank you for your talk. That was really interesting.
Thank you.
Very good.